Hello students, welcome to this session. In this session, we will be covering sinking funds, capital recovery factor and perpetuity. These are extension of time value of money and these are special applications of time value of money. Now these parameters are essentials in financial planning and taking day-to-day personal finances as well as the corporate financial decisions. So the learning objectives of these sessions are to understand the concept and applications of following in corporate as well as personal finance. Sinking fund factor, capital recovery factor as well as the perpetuity. So we'll discuss this one by one. So there are many real life situations relating to investment decisions and financial planning. These situations are faced by both corporate houses as well as individuals. Corporates wants to plan for replacement of machinery, amortization of loan, evaluate financial feasibility of forthcoming projects, and invest surplus cash. Now, suppose a company has purchased a new machinery today, and the life of machinery is 20 years. So, after 20 years, this machine needs to be replaced and it will become obsolete. So, if the machine costs today X amount, say 1 crore rupees. So after 20 years, naturally, the company requires more than 1 crore rupee. So if the company does not plan for replacement of that machinery today, then at the end of the 20 years, purchasing that machine, new machine, would become very difficult. This will lead to huge cash outflow and unnecessarily create financial burden on the company. So, what is the way of planning for replacement of this machinery? The company can apply the concept of sinking fund. So, company want suppose 1.5 crore rupees to replace that machinery after 20 years. So, the company will have to set aside from today every year certain amount so that the desired amount is accumulated at the end of 20 years. So company can apply the sinking fund factor, sinking fund concept and decide that what would be the amount that need to be set aside every year and invested at a desired rate so that the desired amount, that is 1.5 crores, is accumulated. Now very often when we go for financing, we ask the manager that what would be the EMI. Corporates also need to finance their equipments. So the concept of time value of money could be applied for amortizations also. That is, the capital recovery factor concepts could be applied for amortization of loan. So in this session, we will be covering how to apply the sinking fund concepts, capital recovery factors to solve our day-to-day corporate problems as well as the personal finance problem also. That is planning for retirement, building a corpus post-retirement, uh, building a house post-retirement at my desired place. So in this case also we can apply the sinking fund. So these factors, that is capital recovery factor as well as the sinking funds, these concepts could be applied for solving the real life problems of corporates as well as individuals also. First of all, we will try to understand what this sinking fund is and what is the concept of sinking fund factor. So sinking fund is the periodic amount that is required to accumulate a specified sum by the end of desired time period at the required rate of return by applying sinking fund factor. As I said, Suppose I want X amount 10 years from now. Naturally, I need to plan from today. Every month, I have to save from my salary and invest in a scheme, maybe SIP, maybe RD, so that I get the X amount. So, what is the amount that I should save every year to get the X amount or the desired amount? So, in order to calculate the present amount, periodic amount, that is the NBT, we can apply the concept of sinking fund. So, what is this sinking fund factor? Is the factor used to calculate the NVTA. So, this A need to be calculated. So, this A, in order to calculate, to find out that what is the amount which I should save from my salary every day and invest at the desired rate so that I get that X amount or the desired amount, we can apply the sinking fund factor. So, sinking fund factor is simply used to calculate the present amount or NVT of future sum. Sinking funds are generally created to decide amount that need to be set aside in a fund at the end of a specified period so that the desired amount is accumulated. Sinking fund factor can be used by corporate houses to create sinking funds for replacement of machinery, amortization of debt, preference shares, or planning funds accumulation for some specific purpose. So, the process of sinking fund. So, first step would be set the target, that is the future amount. That is what is the amount that you want at the end of the time horizon, suppose n years. It may be 10, 20 years, 50, 30 years or post retirement. So, you have to decide what is the amount. Suppose I want to buy a house 10 years after my retirement. So, my estimation is that if I buy a house in NCR after 10 years, I need 5 crore rupees. So, from today I have to plan for this. So, what is the amount that I should set aside from my salary so that I get 5 crore rupees accumulated on retirement for buying the new house at the place of my wish. So, this future amount means you have to decide that what is the amount that you want at the end of the certain time period. Next is that you have to choose the required rate of return. Means you would be investing that amount in certain scheme. So, the required amount may be, you have to see the scheme where suppose you are investing in monthly income, suppose you are investing in RD of a post office, it may be paying you 6%. So, this is the required amount. You have to explore that which scheme or which investment avenues offer you the required rate of return. So, you have to choose. Next is you have to compute the sinking fund factor, that is K is the required rate and 1 plus K raised to the power n minus 1. And finally, you will get the A value. If you multiply the future amount, that is with the sinking fund factor, you will be getting the amount that you should set aside every month from your salary to get 5 crore rupees for the retirement. Step 5, deposit A each period, funds grow to future value of annuity at the end of the year. Now, the formula. So, there is shortcut formula also. So, sinking fund factor is what? It is simply the reciprocal of future value of NVT. In the previous sessions, we have discussed how to calculate the future value of NVT. So, if we divide the future value of NVT factor with 1, 1 divided by this, we will be getting the sinking fund factor. So, sinking fund factor is what? It is simply the inverse of future value of NVT factor. It generally range between 0 and 1. Now, we will see that how to calculate the NVT amount or the periodic sum that we should set aside. So let's recall the future value of NVT formula. So future value of NVT formula is what? Simply A into 1 plus k raised to the power n minus 1 divided by k. This we have discussed in the future value of NVT session. So what we intend to calculate means we want to know that what is the amount that we should set aside today or every month from our salary to get the desired amount. We need to calculate this. As it is said, that is nothing but simply inverse of compounding. So this formula is simply modified as A, this is the annuity amount, this is future value of annuity into K because it is the reciprocal. So when we solve this, we will be getting this formula. So the annuity, the amount that we need to set aside every month from the salary could be calculated by applying this formula. So future value of annuity, this is the fund accumulation, that is 5 crore rupees which I want to accumulate it. Required K, it may be 6%, that is the return from the investment. Suppose I am investing in post office scheme, then it is 6%. So on solving this, we will get the value of, we will getting the amount which we should set aside every month so that we get the desired amount of 5 crore rupees. Let's try to understand this. A company wants to accumulate 8 lakh rupees in 6 years to redeem a debenture. Company might have issued a debenture and it want to redeem it. Now on redemption, this 8 lakh rupees outflow will create a financial burden on the company. So company need to what? Plan for this retirement from day 1 on itself. So the company wants to know what is the amount that it should set aside every month from its investment. So the company intend to know what is the amount that it must set aside every month or every year from its earnings so that a desired amount, that is 8 lakh rupees, is accumulated for redemption of the principal amount. Because generally in case of a loan, what company do? Company pay interest every year and on maturity, because this is a redeemable debenture, on maturity the principal amount plus interest has to be redeemed. So what company has done, has set aside certain amount every year from its earning and investing at 9% annually. So what is the amount? This need to be calculated. So we will be applying our sinking fund factor. See, we are applying the sinking fund factor for rupee 1, this is 1.1. So when we multiply with 8 lakh, means every year company must set aside 1,06,400 rupees and invest in a deposit scheme offering 9% for 6 years, so that the company will be getting this desired amount. Now let us try to understand the another important concept of time value, that is the capital recovery factor. This factor is also essential for financial planning. Particularly, this factor we can use for planning our repayment schedule, or banks can use this capital recovery. Suppose you are working as a credit manager and you want to calculate the EMI for your customer, you can use this capital recovery factor. Now let us consider another practical situation in business and finance. The manager wants to borrow for equipment rupees 75 lakhs for 3 years at 10.5% from his banker. Now he wants to estimate EMI. Which concept he must apply? In this case, present value of NVT is simply 25 lakhs. The manager wants to estimate the annual installment, which is in the form of NVT. So the annual installment or EMI, that is equated monthly installment, can be calculated using capital recovery factor. Capital recovery factor is the NVT of certain cash flows today for a specified period of time and at the required rate. So let's try to understand the concept of capital recovery factor. Capital recovery factor is simply the reciprocal of present value of NVT factor. So in the last session, we had discussed how to calculate the present value of NVT. So this is the, if we divide the present value of NVT factor with 1, we will get the NVT amount every year. So A is what? Present value of NVT into capital recovery factor. We will get the NVT amount, or we can solve this also. Capital recovery factor is used to determine equal installments that recover present value of amount PV. Installments, it may be monthly, it may be annual, can be calculated using capital recovery factor. To compute capital recovery factor, we need to calculate the capital recovery factor. We need to find out CRF. So CRF is used to prepare the loan repayment schedule or amortization schedule. So capital recovery factor is nothing but it is simply the reciprocal of present value interest factor of NVT. So this is the present value formula which we have discussed in the previous session. So capital, what we will be doing? We will be simply 1 divided by present value of NVT formula, we will get the capital recovery factor. And if we, so capital recovery factor is, as it is the reciprocal, we can, this is the another formula of present value of NVT. Okay. So capital recovery factor is what? K into 1 plus K. Because if we solve this, simplify this, on simplification, we will get this capital recovery factor, this formula, because this would be over here. So K. So on simplification, we will get the capital. So the final formula of capital recovery factor is what? This one, which is K into 1 plus K raised to the power n divided by 1 plus K raised to the power n minus 1. So this will give you what? This will give you the NVT amount or the annual installment amount. So the first step is what? Identify the loan amount P, interest rate I, and term N, that is the time period. Compute PVAF or directly find CRF. We can do this. Calculate equal installment A is equal to P into capital recovery factor. Prepare amortization schedule for each year. Split A into interest, that is K into opening balance and principal. We will be learning in the forthcoming slide. Now, the problem for preparation of repayment schedule, because the manager intends to estimate that what would be the EMI for purchasing an equipment of 75 lakh rupees for 3 years, and if the bank charges rate interest of 10.5%. So he will be applying the capital recovery factor. So installment amount for the firm can be calculated as this way. So A is equal to, so this A modification and simplification, present value into this. So 25 lakh rupees is the amount which is being borrowed. So on solving this, we will be getting the installment of, that is 4,000 rupees would be the installment of the company. Now, once we have calculated the installment, what we can do? We can prepare the loan amortization schedule. So we will be learning in the forthcoming slide. The company borrowed 3 lakh for 4 years at 10% and want to pay at equal end of installment. Compute the annual installment and the repayment schedule. So the capital recovery factor is calculated over here, and the annual installment amount is 94,000 rupees. Means in order to redeem this 3 lakh, every year the company has to return to the company 94,650 rupees. Now this comprises of principal amount plus interest. Okay. Now see the repayment schedule. This is the amount which is borrowed by the company, which is called the principal outstanding at time 0. Now we have calculated the annual installment, which is 94,650 by applying the capital recovery factor. Now we will split this into two parts. So this comprises of interest component as well as the principal component. So what is we will simply calculate the simple interest on this at the rate of 10%, which would be 30,000 rupees. So we will be subtracting the interest component, and this will give you the principal amount that is redeemed every year. So after 1 year, what is the principal outstanding? This will be 3 lakh minus 64,650. We get the principal outstanding. So at the end of 1 year, this is the loan amount, principal amount, which is left with the company. Same way, then again in the second year, we will calculate the interest for the second year at the simply 10% of this amount, which will be 23,535 rupees. So this is the annual installment. We will subtract this interest amount. We will be getting the principal amount. Okay. Another. So the principal outstanding at the end of the second year is 1,64,000. And finally, again, say this is the installment amount for the third year. Again, we will calculate the rate of interest applicable on principal remaining balance, which is at the rate of 10%. We will get this interest as. So we will subtract this interest amount and we will get the principal amount in the third year also. Okay. And so finally, at the end of 4 years, we will be solving this. So on this, interest is 10%. This, and from the installment amount, we are subtracting this, we get the principal amount of this. So finally, what we find that approximately this entire amount is redeemed. This is due to simply due to problem of approximation. So see the practical application of capital recovery factor. So if you are working as a credit manager and you want to plan, or if you want to, so if you are working as a credit manager and you want to prepare the repayment schedule for your client, you can use this capital recovery factor. These schedules could be prepared monthly basis also by simply modifying the basic formula, that is the frequency of compounding. If you want to calculate for monthly, we had already learned the frequency of compounding, that is K would be divided by N and N would be multiplied. So these basic formula, if you want to calculate the monthly installment, then we can modify the formula. Now the another concept which we will be discussing is the present value of perpetuity. First of all, we will try to understand what this perpetuity is. An infinite series of equal cash flow occurring at regular interval for indefinite period at a time at a constant rate. So irredeemable bonds, irredeemable preference shares, or other form of investment that offers an investor a perpetual cash flows can be valued using present value of NVT or perpetuity. So the key assumptions are that constant cash flow means perpetuities are always the case of NVT, equal cash flow. But why we call this perpetuity? Because the time period is infinite over here. And the rate will also remain fixed. So in the first occurrence of perpetuity take place after 1 year from today, theoretically the present value formula can be written as this way. So see over here, up to in the past example we have which we have discussed, we have seen that the terminal cash flow was having this N, means time period was defined. Now in this case, in case of a perpetual, this is infinite, it is not infinite, its time period is not defined over here. So for the purpose of calculation of present value of perpetuity, it is simply A divided by R. A is the NVT amount, because perpetuity is also NVT, but not for definite time period, but for indefinite time period. And R is the required rate of return. In perpetuity, time period N is so larger that it approaches towards infinity, and therefore the expression 1 plus R raised to the power N tends to become 0. That's why this formula is simplified in this form. Now Mr. Raj's job is pensionable and he is expecting a pension of rupees 10,000 per month for his remaining life. He has a choice of getting a lump sum value of for his pension. What lump sum payment he can expect if discount rate is 9%. Now in this case we can apply the present value perpetuity concept. So present value formula, if we apply this on solving, he can expect what? 13 lakh 33,333 over here. So his pensionable amount. So this is the annuity amount for indefinite time period, because for entire life this is not defined. Time period is not defined over here. N is not defined in this case. As N is not defined, so this would be the case of perpetuity. So simply by applying the simple formula, we can solve this equation. Now application of perpetuity. It is used for valuation of financial instruments, particularly irredeemable bond or perpetual coupon bonds, annuities and endowment plan also. Second application is that investment analysis. We can use it. There are certain capital budgeting decisions. We need to assess it. So, which is a certain investment that generate constant return indefinitely. So, if you want to analyze those investment where the return is for indefinite time period or time period is not defined, we can use this also for the purpose of calculating the NPV of a project which is generating cash flow for indefinite time period. Corporate finance also, that is estimating the future value of constant cash flow from project or investments. Another, very often we must be listening about that in how many, in what time period my amount would be doubled. So several times you may be willing to know how long does it take to double 10,000 rupees at a compound rate of 8%. So there is simple rules, that is the rule of 72 we can apply over here. And the years to double is, that is 72 divided by k, that is the required return. So if we divide 72 with k, that is 0.08%, we will be getting, means in 9 years your 10,000 would be 20,000 rupees. So this is one of the simple application of time value of money. Apart from the above specific application, time value of money can also be used for following purpose in managing investment by corporates, that is capital budgeting decision, estimating cost of capital, that is dividend decisions, valuation of securities. Thank you.